My name is Kyle Robler. I'm the Director of Product Marketing here at BlueCat, and it's my pleasure to welcome you to the BlueCat Cloud series of webinars. If you joined us in January, it's my pleasure to welcome you back. So this is a series of 3 that we're running. The first in January was all about regaining control of DDI and accelerating the delivery of critical DNS services to cloud teams. If you missed that one, you can go back and watch it on demand. You can find it on bluecatnetworks.com, our webpage. You just go to the resources tab. It's the first webinar listed there. You can easily watch that, take notes, forward it to your colleagues. A lot of good stuff in that one. So if you're just joining us now, you can watch that one. Today is our second in the series. This one is about taming complex DNS forwarding in the cloud using something we call intelligent forwarding. And then if you come back and join us, we hope to see you again in a month's time on March 23rd. We'll close out the series of webinars with our third and final. This will be an insider look on into BlueCat Integrity 9.3. BlueCat Integrity is our core DNS DDI platform, and we have a new software release that will be GA'd in March, and that's an insider's look on that. So we hope to see you on March 23rd. With me today to go through our topic of taming complex DNS forwarding is Scott Penny. Scott's our Vice President of Strategy. He'll be doing our content today. Welcome, Scott.
Hey, thanks, Kyle. Good to be back.
I just can't help but notice that you are indeed wearing your cloud webinar shirt from our last series that you said that you would wear again.
You know, I always follow through on my promises. I was actually doing a webinar this morning with a bunch of folks over in EMEA, and somebody referenced this as my my waistcoat, which I had to actually look up, but apparently it means vest in English. So
very nice.
English, you know.
Very nice. I did not wear the same shirt, but I think I'm in the same color scheme, so hopefully I remain cloud compliant as we go through the webinar here. So let me just walk through the agenda so everyone has an expectation of what to expect here. We're going to kick it off with a quick summary of what we talked about last time, and then introduce the 4th challenge with cloud complexity, the compounding complexity due to DNS forwarding rules. And then Scott's going to take you directly into a demonstration where we will show you how what we're calling intelligent forwarding helps to address that problem. Those 2 pieces will take about 20 minutes, and then we will open the phones for Q&A. You can ask questions in the chat box. You can ask in the Q&A section. Either way, you can DM us if you're on Slack in our network VIP channel. We'll be checking everywhere for questions. We'll go through that. And then I have a few closing remarks, including an invitation to complete a survey for some research that we're doing. And if you help us out there, there's a small gift card reward as an appreciation for completing the survey. So why don't we start with a quick summary or recap of what we conducted in our last session.
In our last webinar, we spent quite a bit of time talking through, you know, what we see as the 4 critical DDI challenges that come with companies moving to the cloud. And we talked about things like the importance of having visibility into changes that happen in the cloud, being able to extend control over DNS and IP address management, you know, to the cloud so that you still have your central point of control and visibility in your address manager. Talked about how we automate provisioning and how we can help keep pace with the fast, you know, pace of change that happens in cloud environments. So if you didn't see that webinar, I strongly encourage you to go watch the recording for that. What we're going to do today, though, is very specifically hit on the 4th point, which is talking about compounding complexity in the cloud. If you think about what's happening in the world of DNS these days, I'm creating islands of DNS all over the place. You know, I have probably still islands of DNS in my data center. You know, maybe I still have some DNS on Active Directory or Microsoft. I've got maybe some old bind servers. I've got my BlueCat address manager, which of course is where we want everything to be. And that's complicated enough. But when I start to deploy DNS information to Azure, to Google, to Amazon, now I've created another mess, right? I've now got islands of DNS or silos of DNS out in the cloud that my users actually need to still get access to. And figuring out a way to get DNS queries to route properly to all of those different silos of DNS is really challenging, especially when we consider some of the limitations that traditional DNS has if you're using bind or something similar. So what we're going to talk about today and show today is how we can make this a lot simpler. All right, so let's look at this complexity problem in a bit more detail. So as I talked about earlier, our key problem here is really that we have this tangle of DNS forwarding that would be required to connect all these little silos of DNS that I've created, and really the only way to do that using traditional DNS capabilities is to do things like conditional forwarding rules, maybe creating custom views within a DNS environment so that clients coming from a certain location get a different experience than people coming from a data center versus a remote office or a branch office. And that works. I mean, you can certainly make that work. The problem with it though is it gets really, really difficult to manage, and it becomes sort of like a house of sticks or a house of straw, right? Where I keep piling more customization and more logic on top of logic, and at any point if I make a mistake, I could bring the whole thing down, right? It's fragile, right? And one of the things we don't like in a piece of critical network infrastructure is fragility. So what we want to do is we want to make this simpler and more reliable. And so our solution for that is what we call intelligent forwarding, which is, you can think of it as almost like a routing table for DNS, where I know where all of my DNS data is. I can define which DNS data sits where. And anytime a client makes a request, I can look at my routing table and I can say, oh, you're looking for some bit of DNS that probably is hosted in Azure. So why don't you go check Azure? And if I'm wrong, if maybe it wasn't in Azure, there might also be a copy of that in Amazon. So if it isn't in Azure, go over to Amazon. So we can use this logic in this sort of routing table to reduce a lot of the complexity associated with those forwarding. The other thing we can do with it though is we can say, you know what, there is no reason why somebody at my branch office in, I don't know, Russia needs to have their DNS query for Google Russia routed back to a data center in London. I mean, it really makes no sense. So I also should be able to configure my DNS and my routing table to say, look, if you're trying to do something that we know is an external domain on the internet, don't bother with that. Route it to a local ISP in Russia. That's going to give my user a more performant experience because I'm going to be, consuming resources from a local Google data center. It's going to give them a more appropriate experience because that should be localized in, Russian. So it's not going to come up in English or French or Dutch. It's going to be in a local language. And it's going to save me a whole bunch of money on WAN costs because instead of routing this traffic back and forth to my data center in London, I'm just going to be using a local inexpensive ISP link to get at that. So to do all of this, we're going to be using our edge solution, and we're going to be talking about a concept called namespaces that allows us to sort of build up this routing table and overcome some of the challenges that come with these silos of DNS and make the user experience much easier, much faster, and much more secure. All right, so let's see this intelligent routing or intelligent forwarding in action here. So I'm working in an environment that's built the exact same way as we built the AWS environments in our last webinar. I deployed a BAM, BDDS, some other things via Terraform, but in this case, I also deployed some records into Amazon's Route 53 DNS because I want to show how these silos of DNS sort of are created and interact. So I'm going to log into a test client here. That's out in that same VPC. And let me show you what I'm working with here. So just to make things simple, I've created some host file entries to be able to get at the various DNS servers. So I've got a DNS server for Route 53 here. I've got a BDDS that I've deployed in Amazon. I have a BDDS that I've deployed locally here in my lab, in my home office. And then I've got an edge service point, which is actually capable of doing this intelligent forwarding. So these are the three things that I'm going to be interacting with today. The configuration that I have, so if I go over here to my AWS BAM, in my BAM, I've created a server. So I've got two servers. So I've got a BDDS here in my local lab that I talked about. That's that .252. I've got into BDDS in Amazon here, this 11.201. So those are my two servers. And then if I go here into DNS, I've got two top level domains. I've got an AWS lab.aws for things that I'm hosting in Amazon, and then I've got a lab.local. And if I look at lab.local, I've got a couple of host records here for my BDDS and for a Linux box that I'm using here. So that's pretty much it. In Route 53, I've deployed lab.aws up here in Route 53. So notice that's the same name as the thing that I've deployed to my BDDS. And we'll get into some use cases here, but I may have things in Route 53 that are duplicated in my BDDS, and there's some very good reasons for that, which I'll talk about. But just to show you real quick, in Route 53, I've created this lab.aws zone, and I've created some records in here like cloud service and critical and mail and some other things that we're going to play with in a bit. So that's the environment. I've got things in my lab, I've got things in Amazon, I've got things in Route 53, and of course we've got things on the internet. So let's talk a little bit about the client experience here. So whenever I'm doing anything in a cloud environment, there are always going to be cloud resources that I need to have access to. So if I'm using, in Amazon terms, elastic load balancers or things like that, those are always going to have records in Route 53 that I'm going to be able, or I'm going to need to resolve. And those records probably don't exist anywhere else. They shouldn't exist anywhere else because they're highly volatile. They're going to change all the time. But from a client standpoint, I need to be able to actually get at those records. So in this case, if I'm here in Amazon and I dig at Route 53, I'm going to want to get to something hosted there. So just using my the configuration that I have, I'm going to look up cloudserve.lab.aws. So one of these things that I defined in Route 53. Okay, and that exists, right? So in Route 53, I get a no error, and of course that's right here. That's the record that I deployed via Terraform. Okay, great, that works just fine. However, I have another resolver up in the cloud. I have that BDDS that I deployed. So AWS BDDS, and if I look at that record in that authoritative server, well, that record doesn't exist, right? That's only in Route 53. It's not in my BDDS. All right, so here I've sort of shown that I've got two authoritative, things that I need to manage, or I need to be able to get to. I need to be able to get to Route 53 DNS, and I need to be able to get to my BDDS. Okay, so that's one thing. The next thing that I'm going to want to do as a DNS administrator in the cloud is I'm going to want to have corporate managed zone information in the cloud, right? And I showed you in my BAM, I've got this lab.aws zone that I pushed up to a lab BDDS. And so that's where I'm going to control a lot of things, right? I'm going to create records in there that my services need or that my users need to get access to. So to get at those, of course, I'm going to dig at my AWS BDDS, and let me look up, let's see, BDDS.lab.aws. Okay, there's a record that's sitting in there, right? Here's this .201 in my address manager. If I go back to not lab.local, I want to put to lab.aws, .201, there's that record. Okay, so fine, so I've got that. But of course, if I was pointing to the Route 53 resolver, nope, it's not there, right? Again, 2 islands of DNS. Now, one of the things that people overlook a lot is, okay, I've got DNS in Amazon, I've got DNS in a BDDS in Amazon. All of these things that are running up in this Amazon cloud are probably going to need to get access to things that are back on my local network, right? So I may deploy all kinds of stuff out in the cloud, customer-facing services. I may deploy, any number of things. A VPN concentrator. A lot of people are putting VPN concentrators in the cloud these days. But those users that are going through that VPN concentrator, they're going to need to get stuff that's still back in the data center, my financial systems, or some database or something else. And so, how do I get the devices or services in AWS to be able to get to that stuff? Well, that becomes a little bit more challenging because if I ask Route 53 for something that's on premises, like for example, my Linux server, local, well, it doesn't know about my local stuff, so I get an NX domain. If I ask my AWS BDDS about it, oops, hey, I spelled it wrong. No, it's going to give me a refuse because it has no idea what that zone is. The only way that I'm going to get at that is if I look at my local BDDS, and here I get my no error. So now I've got 3 islands of DNS. Oh, and by the way, let's not forget about getting out to Salesforce.com or ServiceNow or anything else. So I've actually got 4 islands of DNS. And this is where things get really confusing because I've got to be able to connect all of this stuff together. So how do I do it? Well, let's talk about that. This is where intelligent forwarding comes in. All right, so we solved this problem with Edge. The way that we solve it is by defining what we call namespaces. And namespaces are a really innovative solution to routing DNS queries. And if I scroll down here and take a look at these, namespaces are essentially a set of rules that define resolution. So if I look at one of my rule sets here for resolution, let me look at cloud zones. I'm going to see that I've defined, oops, that's not the one I wanted. This is the one I wanted. I've defined a set of zones that are going to exist in a certain location. So in this case, I've said for my namespace or my route, my DNS routing rule called local zones, I'm going to say that there's a certain set of zones that are actually in my local network here in Grand Rapids, Michigan. And I do that by building what we call a domain list that says, if the client is trying to get to any of these things, send it to this resolver. So in my domain list here, I've just got lab.local to keep things simple. If you recall, when we were doing our digs, I was going after linus.lab.local. So this would apply to that query. And what this is going to do to that query is it's going to say, okay, you match this. I'm going to send you to this forwarder, the BDS that is sitting here in my lab. For other routes, go back down to where these are, Route 53, for example, I'm going to send these to the forwarder that is in Route 53, this .2 address, right? And I'm going to do basically anything that's in lab.aws or amazonaws.com is going to match, and it's going to go to that forwarder, the .2. And then, of course, I have a namespace for my cloud zones. So where I'm going to send these to the BDS that's up in the cloud. All right, so let's see this in action. Let's run through those scenarios again. So for the first scenario that we were doing, we were looking for something that was only ever going to be in Route 53, so this cloud service. And I noticed that if I send my query right to Route 53, it works just fine. Let's see what happens if I send this through the service point. So let me, once again, show you the service point. The service point's here. It's .205. It's called AWS Edge. So if I dig at AWS Edge and I look for that cloud serve.lab.aws, look, I got it. I got a no error. It routed me to the right server, which in this case was Route 53, and I got the correct address. Okay, cool. What about that thing that I had hosted on my BDDS in the cloud only? Let's try that. So we're going to dig at AWS Edge again. We're going to look for bdds.lab.aws. Once again, no error, because Edge matched the rule, said, you're trying to find that thing? Well, it's on this BDDS that's in the lab, and here you go, no error. And what about, learn how to type. Let me try my Linux server that's back here in my lab. And again, no error. It routed me back to my on-premises DNS server, gave me an answer. And let's not forget everybody's favorite. We also need to be able to get out to salesforce.com or google.com. And there we go. In this case, I didn't show you the namespace, but because this was something that was not on any of my internal zones or in my AWS zones, so I just shot that out to Google DNS for resolution. So instead of having to remember now where all of this DNS data sits, I can just set up namespaces in Edge and you point everybody at that Edge service point, and that service point is going to make sure that I get where I need to go without error. The other really nice thing about this is every single bit of activity that I'm doing is logged. So I can go back into my Edge console and I can look at every single one of these queries that's happening, and I can see which route it took. And if I start to see failures or slowdowns in DNS, I can actually use that data to help me troubleshoot the issue and make improvements. So for example, if I'm trying to go to something external and my namespaces are misconfigured, I might be hitting an on-premises DNS server, then a cloud-based DNS server, and only if those two fail do I go out to Google DNS. Well, that's not optimal, right? So I might be getting high latency on those queries. I'd be able to spot that within Edge and then make changes to my namespace accordingly to optimize that, and reduce, improve performance, reduce the likelihood of failures. So to do that, I basically just go here to my query logs, and I can filter based on a site. And we didn't go into details on this, but sites are sort of where we store configurations. And I can see that my activity hasn't shown up yet, which is of course going to happen when I'm doing a demo. Usually takes a minute or two for data to come up. And I'm pretty sure it was supposed to be on that one. Oh, here we go. Here's some of it. So here was a query that we just did to linus.lab.local. And we can see that this hit the local zones namespace. We can see the latency of that query. We can see who was asking the question. This was my test client out in AWS. And we can see all of the information about the answers to that query. So I won't go to all of these, but I now have a view into this query activity, and I can use that to either control traffic. I can apply policies to this to say that certain clients have access to certain data. I can enforce blocking against threat feeds. I can look for suspicious activities such as DGAs or tunneling. I have a ton of options, and those all just sort of layer on top of the benefit of being able to sort of untangle this nest of DNS forwarding rules, which makes client resolution, again, faster, more secure, more predictable.
Okay, cool. Good stuff. Get my camera back on here. Good. There we go. Good stuff. Interesting bit at the end about the query log. So let me just summarize what we've heard today. Today we tamed complexity. We ensured DNS resolution between cloud and local resources. In order to do that, we used BlueCat Edge and namespaces within BlueCat Edge to define a set of zones and create specific DNS resolution paths. You saw the domain lists that use specific forwarders, so when client queries are matched, they go to where they're supposed to go. And then again, at the end there, we talked about the query logs to verify and get visibility into that intelligent forwarding actually taking place. Looks like there's also probably a wealth of other information in there too. All right, so I think at this point, we can probably open it up to Q&A. Scott, while I was summarizing there, did you see any in the Q&A? I don't see any in the chat box.
No, looking at Q&A, don't see anything yet. Let me check Slack here.
Okay, I did get one. Somebody DM'd me with one while you were going through your demo. So this might be a little bit of a challenge. So isn't namespaces just the same as more DNS forwarding rules? So we're simply trading complex forwarding rules for complex BlueCat namespaces.
Yeah, I mean, so we kind of mentioned this. I mean, the answer is no, you're not. We kind of mentioned this. I mean, you can do a lot of what we were talking about doing here with forwarding rules in DNS, right? I mean, there's a little bit of magic that's going on that makes this a lot simpler. But yeah, you could do that. Here's the trade-off, though. When you have a large environment of DNS servers, you then have to manage all of those conditional forwarding rules on multiple points of DNS service within your infrastructure. It's difficult, if not downright impossible, to automate any of that. So as you make changes, you have to sort of manually go back and make sure that all those rules are still correct. What we're doing in Edge is we're giving you the ability to sort of centrally manage all that very simply and just say, look, here's for anybody, if you're trying to get to these resources, here's your DNS route, and then apply that globally, right? So now I've simplified that administration. We have automation where you can automatically update those things. So for example, if you create new zones or whatever that are internally deployed within BAM, we can automatically detect those and add them to your routing table, right? Your namespace and your domain list. So yeah, you can do a lot of this with conditional forwarding, but you don't want to. And our customers struggle with being able to maintain that stuff over time.
Cool.
Good question.
Cool. I have another one here that says you mentioned cost in the localization and user experience. Explain more about the cost.
Yeah, I mean, it really gets to a lot of the efforts that people have for doing things like SD-WAN and localizing internet access, because backhauling traffic over MPLS networks is no longer the thing to do, right? It's expensive. It's not necessarily the highest performance. It doesn't give you the best kind of localized experience for your users. So if you can take advantage of your local office's ISP link and just resolve things locally and then steer that traffic locally, you really should. I mean, it costs you next to nothing, takes load off your MPLS environment. There's overall cost savings, but and productivity improvements too, just because of the localization and the better performance of those queries and access to those services.
Good, good. Okay, so I'm getting, they're DNMing me today, so they're not using the chat.
Yeah, I guess so.
All right, so the question is, what sort of access is required for Edge? Do you need internet access? Edge as a service? Question mark.
Yeah, so there's a lot of confusion around this one. So this might have come from an internal BlueCat employee. You never know. Edge is what we kind of call a hybrid SaaS solution. So what I mean by that is it's very similar to like Cisco's Meraki, where your service point, the things that are providing DNS service are either on premises as virtual appliances, or they're up in a cloud infrastructure as a virtual appliance, or whatever. You can deploy as many of them as you want. They are configured and managed from a cloud console, and so they have to have the ability to connect to that cloud console on a periodic basis to get updates and things like that. That's not shared infrastructure though. So every one of our customers has their own private cloud infrastructure that manages Edge. And we can do all kinds of things to restrict, IP ranges that can access and all that kind of stuff. So you also have the ability to log all of these DNS queries either in that cloud instance at our cost, or you could do what we call local logging, which takes all of the query and response logs that we gather and shoves them to a local data lake. So if you've got Splunk or you've got some other big data, type of tool, you can just shove it all locally so that stuff's not exposed to the cloud. I should mention though, there's no dependency on that cloud connection. So once things are configured, if that cloud connection goes away or you have an outage, DNS resolution is not impacted. It's all still being done by those local devices. It's not like routing your queries up to the cloud and back or anything like that. That would be silly. So things will just keep on keeping on.
Nice. I think we have time for one more. So this one asked, do you need a service point in each virtual private cloud to be able to access the two AWS DNS server and query the private AWS DNS?
Not necessarily, though. It gets into a deeper conversation about how your VPCs are configured. So the prevailing best practice architecture these days seems to be that customers are setting up shared, like, sort of management VPCs. And if they do that, they're trying to consolidate a lot of this management infrastructure into those shared services VPCs and then service the individual VPCs that are associated with that. And so specific to Amazon, you can do peering relationships between that shared services VPC and other VPCs. And one of the options when you do that is to allow for DNS resolution across those peering connections. So in that case, no, you would just have Edge service points in your shared services VPC. They could then do the resolution across all of the other VPCs. If you can't do that for any reason, then there are some other strategies you could pursue.
Okay, nice. Well, thanks for the Q&A, Scott. Let's close with a couple of closing comments here. The first is, we're obviously very interested at BlueCat in these cloud strategies, and we're trying to learn more about this dynamic of collaboration between the traditional on-site or on-premises network teams, and then the other groups that you'll need to work with. That could be the cloud teams, the DevOps teams, could even be your security, your SecOps teams. So we partnered with EMA Research, and they have a survey that they've developed. It takes about 15 minutes, so if you wouldn't mind going to the link there, I'll also include this in a follow-up email where you'll get a recording of today's webinar, but you'll also be able to access that link there. Very quick to remember, EMA BlueCat. And if you are so generous with your time, 15 minutes to complete that survey, we will reward you with a small gift card there. So we hope that you help contribute to the research project that we have there. And then finally, just a final reminder, if you're already registered for this webinar, you've got a seat for the final third cloud webinar series that we have on March 23rd. And again, that one will be an inside look, a sneak peek into Integrity 9.3. And just to kind of raise your curiosity, I'll be joined by our product management team. We'll show you how to manage overlapping cloud networks like a boss. So stay tuned for that one. All right, everybody, we appreciate you attending. Thanks, hope you got a lot out of it. And that concludes our webinar today. Hope you have the great rest of your day.